try and burn off the top. Hi, my name is Nathan.
And I'm Ryan.
And today we're going to show you how to set up an anaerobic digestion in your home. It's very simple, very easy to do. Everything you see that we have is everything you're going to need. To start off, we're going to be using some vinegar and baking soda. You can find them really in any store you want to go to. They're easy to obtain. Every kitchen should have them. You get them for a couple dollars. We also have some water that we got out of the sink. It doesn't have to be anything special, filtered, or anything else. We have some seed, which we obtained from a local digester around here. And then we have our measuring utensils. We first have a funnel, just to make things a little bit simpler. You don't really need one, but it makes it a lot cleaner. We have some beakers here with graduated marks on them in milliliters. Make sure that whenever you're using any kind of measuring cups for this, that they have that little ML symbol on them. It's going to be very important, it makes it a lot easier. And then we have some measuring spoons here in teaspoons and tablespoon size. Now, we also have what we're going to be mixing our anaerobic digestion in. The size doesn't really matter. You can change what you're doing, alter it for whatever size bottle you have. The important part with these bottles, we have these little pop-off lids that you can find on most bottles. Very simple, just those little ones. You find them on a lot of sports drinks, anything else. All the sizes are the same, so you can really screw off the top and put them onto any kind of size bottle you want. So at this point, you might be kind of thinking, well, you've described what we're going to be using for this anaerobic digestion, but what is it? Which is a very good question. So, Ryan, what is anaerobic digestion?
Anaerobic digestion is the process by which biomass, in the form of animal manure, agricultural byproducts, even cooking oil, which are things we normally would just dispose of, we don't have a lot of use for, can be converted through a process called hydrolysis into simple sugars. Now those simple sugars can then be further broken down by fermentation into acids. Fermentation, if you think about yeast making bread rise or the production of alcohol for consumption, those are examples of fermentation. Fermentation happens with that oxygen, which is where the anaerobic digestion comes from. Those acids that are produced, one of which is acetic acid, can then be converted again by our microbes in our seed into methane gas. So we're going to shortcut all of the step-down process, and we're just going to start with the acetic acid in the vinegar. However, acetic acid would create an environment that would probably kill off our microbes, and then we wouldn't get any methane gas. So we're going to use some baking soda in order to neutralize the acid and make it a safe environment for our microbes to do their work in. I think that's about sums it up, so we're going to hand it on over to Nathan and we'll begin preparing our anaerobic digesters.
Alright, well before we start, for some safety precautions, we're going to be using some glasses and gloves, so we're going to go ahead and put those on. So we've already gone ahead, we got our glasses on and our gloves. We're going to go ahead and start mixing everything that we need. So first we're going to do our baking soda and vinegar. We're going to use our largest measuring cup and add about a half teaspoon of baking soda to it. It doesn't have to be a heaping portion, it can be just about right on the edge. After we add our baking soda, we're going to put it in our vinegar. The vinegar, we're going to be using 1.5 tablespoons worth. Now you can watch it as you add the baking soda to the vinegar. It's going to fizz a little bit. You shouldn't go over the edge of your measuring cup, but it's always fun to watch. Once we have our vinegar added into our baking soda, we're going to make sure that we mix it just by swirling it, get all the baking soda dissolved. And to help it a little bit if you need to, you can add a little bit of water. Don't add too much because you're going to go over how much we're going to be measuring out. So if you want to, you can go ahead and do that. And while he's getting sure that that's all mixed well, I'm going to go ahead and measure out some of our seed. We're going to be using 125 milliliters of this. Again, this is going to be used to help make our vinegar baking soda mix produce methane. So we have about 125. If you go over or under, it's okay. We have this measured out. We're going to go ahead and add it into our baking soda and vinegar solution. And once you have all of your seed added in, you're going to go ahead and raise the total volume up to 250 milliliters using the water. Again, the milliliters is a little ml symbol on your graduated, your measuring cups. We're going to go ahead and mix it up a little bit more just to ensure everything has been thoroughly mixed. And we'll go ahead and get our water bottle and funnel to be able to put it into. As was mentioned before, this is anaerobic digestion. And anaerobic being without oxygen, that means the next step, we're going to have to get all the oxygen out of the bottle as much as we can. We crush the bottle as much as possible to be able to push out all of the air. Now this could be a little bit hard depending on the size of your water bottle. If you have a large one, it's going to take a lot more effort. But try and get out as much of the oxygen as possible. You can go ahead and then put the cap on. It should create a fairly airtight seal. You'll see there might be a little bit of space in there where a little bit of oxygen is. It won't necessarily hurt or hinder too much, but try and get as much as possible. This is what it'll look like once you're done. You can then let it sit out for a couple days, somewhere where it'll be preferably pretty warm. And in about 5 to 6 days, you should see a fairly good production of gas with your bottle expanding. So, the last time you saw us, we went ahead and prepared our anaerobic digestion bottles. What you see now, this took about a few days at 95 degrees for us. When you're making yours, you're probably going to be able to keep just at room temperature. That'll maybe make it last a little bit over a week. Depending on the lower the temperature, the longer it'll take. So it could take a little bit longer for you to get your bottles to look like this. Our next step in the process is to go ahead and make sure, verify, that we have produced methane in our bottles. So what we have with us, we have our lighter. And for safety's sake, we're going to go over to a fume hood that we have here at the lab and burn off from there. So if you need to, we'll follow us over here. We're going to go ahead and light it. We're going to pop it up and squeeze it out very slowly. Another fun way to burn off the methane gas that you produced in your digesters is to get some blowing bubbles, you can find them anywhere, some kind of connecting or hosing, and that way you can connect your bottle directly into your soap bubbles and blow your bubbles into there. And from there you can go ahead and just burn the surface off. So I'm going to go ahead and do that. Take off the cap on this and attach the tubing. And once the tubing's on, we'll go ahead and insert the other end into our bubbles. Hold it down, and you want to hold this down for me, Ryan? I'll go ahead and open up the bottle. We're already getting some bubbles out already. Go ahead and squeeze them out of the methane. Go ahead and close this off and try and burn off the top. So last time we went ahead and burned off the gas that we produced in our bottles, and this time we're going to go ahead and measure how much methane was produced. Now, methane isn't the only gas that is produced inside of our digesters. There's also carbon dioxide and hydrogen sulfide. So what we have to do is scrub off or get rid of this excess gas in order to measure how much methane is produced. So what we're doing, we made a solution of potassium hydroxide, or you can do sodium hydroxide, make it super saturated. Here you can see it in our flask right here. And we're going to push our gas through the system in order to scrub off this excess gas. So what we have before us, we have our bottle hooked up through a tubing to this middle flask to be able to get the gas through it, which will eventually lead into our graduated cylinder. Now we have an inverted graduated cylinder here, and we've measured how much the volume is at currently on the inside, which currently we have 55 milliliters. And what's going to happen as this gas comes through, it's going to displace the water, and we'll be able to subtract the initial volume from the final volume, and that should be our total volume of methane produced. So I have Ryan here to help me do this. I'm going to go ahead and open up the bottle, and if you go ahead and loosen that up, I'll go ahead and slowly push through the system all the gas that's in our bottle. So you went ahead and close it off for me, and then we can measure the final volume inside, which it looks like it's going to be about roughly 255. So then we can take that minus our initial, and then we have our volume of methane that was produced in our bottles. Hold it down, and you want to hold this down for a round?